Alright, in this video I'm going to go over an example on how to determine a sample size for a problem about confidence interval for means. So in this problem we're calculating a 95% confidence interval and we want to be within 2 points. So that's going to be our margin of error. So we want our margin of error to be less than or equal to 2. So to calculate a margin of error for a problem about means, we do z star times sigma over the square root of n. That's kind of the general form. We are going to use z star for this, not t star, because we don't know the sample size, so we wouldn't be able to determine the degrees of freedom. The z star value gives us a conservative estimate. So for a 95% confidence level, we're using 1.96. So it's going to be 1.96 times our standard deviation sigma is 50 over the square root of n. So like with proportions, this is a kind of just an algebra problem. It's a little bit easier than the other one. So first thing I'm going to do is I'm going to get rid of the 1.96 by dividing both sides by 1.96. And I'm actually also going to get rid of this 50 by dividing by 50, so 1 over 50. So I'm kind of doing that all in one step. So that gets rid of the 50, it gets rid of the 1.96. So we're left with 1 over the square root of n is less than or equal to, and when we multiply this, we multiply across, so 2 over 1.96 times 50. Now we need to get n on top, so we're going to take the reciprocal, which means just flip it. So we're left with square root of n. And remember, when we flip it, the inequality also switches. So then we have 1.96 times 50 over 2. To simplify this a little more, we can just divide here. 50 divided by 2 is 25. So that means square root of n is greater than 1.96 times 25. And then last thing we're going to do is we're going to square both sides. So 1.96 times 25 squared, you get 2401. So that means you need a sample size of 2,401 in order to get a margin of error of 2. Alright, so let me show you an example where you're able to actually just plug in some numbers, which makes it a little bit easier. It's a lot less algebra. For this problem, we want our margin of error to be less than or equal to 10, and we're doing a 99% confidence level. So 99% is 2.576. Sigma in this problem is 17 over the square root of n. So to simplify this, what we can do is we can just take an option, plug it in for n, and see if we get that to be less than or equal to 10. So first I'm going to plug in 12 and see where that gets us. 2.576 times 17 over the square root of 12. We get 12.64, so that's not going to work. So I'm going to jump up to 30 and see where that puts us. So I'm going to plug in 30 for n. So this we get 7.99. That's a little bit too big because I want to get as close to 10 as possible. So now let's try plugging in 20 and see what happens. So if I plug in 20, we get 9.79. That gets us closer to 10, which means B is going to be the correct option. So when you plug in 20 for n, you get a margin of error of 9.79, which is as close as we can get to 10.